Hello, welcome back to the next series of the most frequently asked examination questions. Today we're going to go into most frequently asked exam question, which is based on the chapter on halogen derivatives. So without further ado, let's take a look together. So this question is focusing on H2 chemistry taken for the year 2012, paper 3, question 2, C and D. So let's take a look. Predict the outcomes of the following transformation. Join the structures of the intermediate CE and DF. So the CE and DF. So we're going to determine what kind of product can be formed. Now this is some of the questions that a lot of people make mistakes, so I thought it'd be good for us to go through together. So let's take a look part one. Okay, so we have this molecule here reacting OH minus. Now everybody should know anything to do with negative charge or lone pair of electron is known as a nucleophile. Then a nucleophile, what would they like to do? They like to attack your electrophile. So currently you got two electrophile here, delta positive, delta negative, delta positive, and delta negative. And what's the reason? Because Cl is more electronegative than your I. That's why this is electropositive. Now, after your carbon is a delta positive, am I right to say that between your Ci bond and your CCl bond, which is the bond that is actually easiest to break? The one that is easiest to break will be the one that is your iodine. Why iodine? Because iodine, right, the size is much bigger, the degree of atomic orbital overlap is actually much lesser. That's why we say that this nucleophile here will do a nucleophilic attack to the I first and kick away the I. Then from here you can form the product, your nucleophilic substitution. But this reaction only using 1 mole. Now what does 1 mole represent? 1 mole, that means you only got one molecule of OH minus. So you only can react once and no more. So which is why when you draw the product, you only can draw one substituted. So let me show you what I mean. So it'll be OH, then followed by Cl. Alright, so this is your C. So it means you only substitute once. Now let's take a look further on the next part. So the next part here is focusing on, this molecule react with NH3 in ethanol. So what do they do? NH3, right? So what I notice is I still got a Cl. You still got a nucleophile. Can the nucleophile, the lone pair here, let me draw the lone pair here. Can they actually do a nucleophilic attack directly to the carbon here, which is carrying the delta positive and delta negative charge? Of course, so you can do the tag and kick away the Cl. So from here, you should be able to form the target product. So I'm going to draw out the structures. So this is how the structure will look like. That OH, then followed by NH2. And what's the reason? Because every time you use the NH3 to attack, you always lose one H. Then don't forget your CH3. And this will be your compound D. And this is the target molecule of your D. Now let's take a look at the next set of questions. So for the next set of questions, we're going to take a look at this guy. So part number 2. Okay, part number 2 here is slightly a bit more challenging because the molecule is drawn in such a way that, it's a bit difficult to see from in this way. This is called condensed formula. So what we're going to do is we're going to draw the structures so it becomes much clearer. So I'm going to draw out, the skeletal form. So this is the structure of the molecule. You have an acyl chloride together with a Cl group. So you got two things. But you must always remember one thing, that is, which is the one that is most reactive. Okay, the one that is most reactive between this CCl bond and this COCl bond. This CCl bond is going to be more reactive. And the reason is because this carbon here is being pulled by two extremely electronegative atoms, making the carbon here extremely delta positive. Now compared to this guy here, of course, this is pulled by one electronegative atom. It is still delta positive, but it's a bit lesser. So which means that you have a nucleophile here that is your NH2, CH2, CH2, OH. So the N is a nucleophile. It will do a nucleophilic attack faster towards this carbon and kick away the Cl. So it's about the speed of reaction, who is faster, who is slower. So that's why I attack. Now, second thing you may ask me, why the OH don't attack? Now, very simple. The OH don't attack because it's a weaker nucleophile than N due to its higher electronegativity. Now, atom that has a higher electronegativity represent they prefer to hold the electron to itself. They don't want to give out the electron. So they hold it, so they don't donate. But as a nucleophile, they want to donate the electrons. Nitrogen is a bit less electronegative, so it's more willing to donate the electron. That's why it's more willing to attack. Now, if you want to break this bond, the only way is you must use heat. What's the reason? It's like relative comparison. This is very delta positive, react under room temperature. But if you want this one to react, maybe you need a bit more drastic condition. Like say for example, you need some heat to react. So that's why the first step, your E here. So maybe let me draw below. Okay, let me draw below here. So E here should look like this molecule. Your Cl still remain. By your acyl chloride version, it become NH. Then this one will be your CH2, CH2OH. Now we take a look at the next part. Now the next part here, do you notice that they add in something? They say that I'm going to add in sodium warm. Hey, what's the purpose of sodium? So you must recall the purpose of sodium is to remove H plus. So remove a H plus that's attached to something very electronegative. So let's examine the molecule. I notice that I have OH bond. So as you know, OH bond O is very electronegative. So that means the hydrogen here is a delta positive. This is delta negative. So they will remove away the H from here in order to generate a nucleophile. So what I'm going to do is I'm not going to draw out the final structure of the molecule. I'm going to draw the intermediate. So let me just delete this away here. Okay, let's delete this away. Okay, I don't know why sure it cannot be removed, but nevertheless, let's continue. So I'm going to draw the intermediate Cl double bond O, NH, CH2, CH2O minus, because you remove the H. So you know after you remove the H, it becomes a very strong nucleophile. But at the same time, what do you notice? They use warm. Warm means heat. Now, you remember I mentioned before, you want to break this CCl bond. Do you need heat at all? Yeah, of course you need some heat. So that's why the O here, right now it has sufficient energy. It will do what we call a intramolecular attack to the carbon here, which is delta positive, delta negative. Kick away the Cl. Then from here, you should form a target product. So to draw a product like this, sometimes it's a bit tricky. So I use a technique, what we call the ring numbering technique. And let me show you how the ring numbering technique works. You basically start ringing the atoms from the place where the atom join. So let me show you what I mean. This is the first position where it's being joined. So this will be your first, second, third, fourth, fifth, and sixth. So basically this is 6 carbon ring structures. So I'm going to draw, there's a 6 carbon ring, a 6 member ring structure to be exact. So I'm going to draw a 6 member ring out. Okay, not necessarily it will be like that, but the idea is to give you that, oh, I can draw a 6 member ring first. Then after which, I want you to number the ring, just like what you see here. So go to day 1, 2, 3, 4, 5, 6. So I'm going to do what we call a matching game. What am I matching game? 1, match with this. So you match with this will become an oxygen. Because this one is oxygen, so match with oxygen. This is CH2, this is CH3, this 4 here is NH. So I'm going to draw a N followed by a H here. Then after which, what do I have on the number 5th position? A double bond O. So I'm going to draw a double bond O. And after which, let's double check. This one is a CH2. So this is complete the molecule. So which means that this molecule here is actually your compound F in this case. Alright, I hope you have enjoyed these videos. So remember to subscribe, and if you want to keep on watching some of the most frequently asked examination questions. So we always post H2 chemistry, IP, and O-level examination questions. Sometimes we also post video lessons that's focusing on certain topics that most students face off. So definitely you want to do some commenting below so I don't know that, hey, I know what is the problem you're facing, so I can create the videos for you. And I hope you enjoyed the video. And I'm Dr. Ao here, I'm signing off.